So this is MySQL performance for application developers. And a quick blurb about me, as it was just mentioned. I have 21 years experience with MySQL. A lot of people know me through my website, which is hackmysql.com. I also have written and continue to write and maintain a lot of open source tools. Probably some of you might know me from Percona Toolkit, because for 8 years I was one of the lead developers on Percona Toolkit. Not any longer. And a few years ago, I wrote a book, which this talk is based on. That book is Efficient MySQL Performance, published by O'Reilly. So this talk is an efficient path through the maze of performance topics. And as the little blurb about this talk in the schedule says, the intended audience is for application developers, especially those people who are new to MySQL or new to MySQL performance, who never really quite crystallized or found the foundation of understanding what MySQL performance is really about. And that's understandable because, as I'm sure you all have experienced either with MySQL or any other database performance can be a pretty complicated topic. There's a lot of things that you can learn, a lot of misinformation or out-of-date information, and you generally run into these cases where it depends, everything depends, and it's unclear, especially for new engineers, say somebody who just graduated college and it's their first job. Where do you start? What should you learn first? What should you learn second? What should you learn third, etc.? How do these things build upon each other to give you a true foundation of understanding what it's all about? And that from there you can use that foundation to obviously improve MySQL performance for whatever application you're working on, but also use it to go deeper into more advanced topics. And my 2 decades with MySQL, the reason why I wrote that book is specifically for this, to give application developers this reference point. The book is about 330 pages. This talk is a lot shorter, about where to start and where to go. So that way you don't get lost in this maze, lost in this dark forest of all these topics and it depends situations. So in this presentation, like the book, it is an efficient path through the various things you could learn, but these are the most important things to learn, in that I plead new engineers to please learn them and apply them, because it'll really make your life, your work life and life with MySQL a lot better. So the full presentation of this talk, again, usually about an hour long, I go through these 8 things. Number 1 is query response time. Number 2 is indexes and indexing. Number 3 is data storage and access. 4 is sharding. 5 is server metrics. 6 is replication. 7, transaction and data locking. And 8, talk about performance in the cloud. But again, since this is a 30-minute talk, I'm going to have to really focus the presentation down to these 3 things. And there's still a lot to say. In fact, I've done a 2-day version of just presenting these 8 things. And again, the book is over 300 pages, because even though this looks like a really short list of things, like, oh, I can go learn this really quickly, there is a lot to kind of dive into each of these steps. But again, the point of this talk is, now that you know what the steps are, at least this is the path I would lay out for new engineers or people new to MySQL. Follow this path. Spend time learning about query response time. What's that all about? Then spend time learning, like truly learning about indexes and indexing and so on and so forth. And if you follow this path, you will create for yourself a very solid foundation, which again, will just save you a lot of time and your company a lot of time, presumably being responsible for MySQL databases. So let me first start by saying, don't worry about taking pictures of the slides or writing this stuff down or remembering it. All of this information is already on my website. These slides are already on the website. I've been told that this is being recorded and will be available online later. So for right now, you can just listen and follow along. hopefully, find some amusement and some anecdotes I'll tell about these first three things. So again, it's already online. You can access it later. No worry about that. One more bit of housekeeping so you can understand how this information will be presented. First, I'll have these slides where here on the left-hand side of the slide are the points that I want to make and the points that I'll talk about. But then at the end, I will have, on the right-hand side of the slide, not shown yet, I will have some actual action items, things that I would really encourage you or engineers to go do, to actually take these points and this knowledge on the left and then go apply it. Because really, it's important that this information be practiced, and that's what I hope that people get out of this. First, some learning, but then also some concrete actions and steps they can go do. Not now, of course, because we don't have time, but again, reference it later and go do these action items that I'll list here later. So that's how the slides will be presented, the general format. So let's get into it. The very first point that I like to make, and actually the very first sentence in the book, is performance is query response time. And there's more to that statement than people realize, but over the years of presenting this, I have come up with a way to help people understand this point, and I'll show you how and why. Why it is that performance is query response time, why response time is the most important metric. And sorry, let me back up a little bit and say, in case there's anybody super new to all this information, what do we mean by response time? Quite simply, how long it takes MySQL to respond to queries, both individual queries and in aggregate. So how much time does it take for the user, your application, the user of your application, to get a response back from MySQL? That's what we mean by response time. Sometimes people call it latency. I have my take on that. I call it response time. So again, response time is the most important thing. Performance is query response time. And I'll give you an example of why. So here we go. There we go. That was about 10 seconds of silence. Maybe an awkward silence for some. But what it goes to show is that query response time is the only metric that your users feel, that they experience. Just like we experienced that 10 seconds of awkward silence. It's not really awkward for me. I actually can't see most of you. They say the lights are kind of blinding. It is kind of blinding. But that time is what users experience. That's why query response time is the most important metric. It's not other things like rows modified or QPS, or there's literally hundreds of metrics. And I'm not saying those aren't important. Of course, those other metrics are important, but a user doesn't experience, oh, this query is accessing too many rows. Well, they don't experience 1,000 rows access versus 10,000 rows access. But if your query is taking 2, 3, 10 seconds to respond, your user actually experiences that wait time, just like we experienced 10 seconds of silence. So that's why I say performance really is query response time. And if you take nothing else from this presentation, perhaps nothing else from the book, you can use this as a starting point to have in your mind, what am I doing? I am trying to make these queries just return faster, to make MySQL respond faster. You can use that as a guiding star, a North Star. And even if you don't follow this path, although I hope you follow this path, focus on reducing response time. Don't get lost trying to reduce other metrics which may or may not actually affect response time and have an impact on your users. So the third point that I like to make, and it's a weird one, is that MySQL does nothing. And what I mean by that is, over the years, so many times I encounter engineers, application developers, who say that it's MySQL is being slow. Well, it's not, because when MySQL is not given an application workload, what is it doing? It's not doing anything. I mean, technically speaking, there are some background processes and other stuff, but in general, if you're not executing queries on MySQL, then MySQL just sits there idle. And there's a lot of application engineers who don't see it that way. I've come to think that they see it almost like a hospital that's busy, and you go to the hospital and you have some sort of injury and you're waiting, right? And you really want to like see a doctor, but the hospital is busy and the doctors are busy, the nurses are busy, everything's taking a while and you're waiting. And you can say in that case, oh, well, the hospital is busy, therefore that's why I'm waiting. And sometimes I think that application developers see the MySQL server like that, like it's a busy hospital inside, and I just have to wait for this other stuff to clear out before I can see a doctor. It's not actually that way. Presuming, of course, that you don't have some sort of shared tenancy model and like noisy neighbors on your database, MySQL is like an empty hospital, and all the doctors and all the nurses are there. There's no other patients. They're just waiting, and you show up, and you can, receive services immediately. That's really what it's like. So really, it depends on what you're doing. When I say you, I mean the application. It really depends on what the application is doing to MySQL. So that's the parenthetical note there. MySQL isn't slow. It's what the application is doing to MySQL that makes it slow. And again, sometimes that seems like common sense, but almost on a weekly, monthly basis, I deal with engineers who don't see it that way. They think there's like these gremlins, again, like a busy hospital and something inside the database, and hey, DBA, go fix that thing inside the database so that my application workload can be fast. No, it's actually, what is the application workload doing to MySQL that's making it slow? So these points of view are important because, again, they set you on the right path to understanding what performance really is and what to do about it, what to learn. So in this case, don't think it's the database is slow. MySQL is actually very fast. It's what the application's doing to it. Third and last point on this topic is it's not uncommon to find that application developers don't actually know what's going on inside the database, meaning what their application is executing on the database. So there's two different points of view here. If you are the application developer, please go find out. Because, and I'll talk in a moment how to do that. Because if you don't know what is going on inside the database, then it's going to be a real hard time fixing it. Because whatever that is what you need to analyze later and fix. You probably don't need to tweak MySQL itself. As we're celebrating here at this conference, MySQL is a 30-year-old database. Pretty much all the, say, low-hanging fruit in terms of poor performance due to inefficient internal code, all that stuff's been worked out. There has been, over the 30 years, a lot of brilliant people, people from academia, industry, experts who have fine-tuned the database. It's fine, but it's the application, again. You have to know what it's actually asking the database to do. And a lot of application engineers don't. So again, if you are the app developer and you don't know, maybe you just joined the company or inherited a new project, go find out. The other side of this perspective is management or DBAs and other people. It's important for managers to know you might presume that the application developers know what the application is executing on the database. I wouldn't presume that anymore. So from the management side, go ask the application developers. Show them this presentation, buy them a copy of the book and say, hey, please go find out what this application is doing to the database, because that's really the heart of MySQL performance, is the response time of those queries. So, like I said, when I'm done talking about the points, these steps that I present are what I hope people will do after the conference. So in this particular case, go choose a tool to analyze query response time. This comes different names, sometimes query metrics, query analysis, something in that ballpark. At this point in history, most tools present query metrics. But again, the name varies, but query metrics, query analysis. So go choose a tool. An open source tool that a lot of people have heard of is PT Query Digest that consumes the slow query log. So choose a tool, there's lots of them. Then enable and configure query metrics, because you do need to do that. If you're not a DBA, this link goes to my website where I talk about how to do that on various platforms. You do need to enable and configure it, as most software things. And then number 3, analyze and fix those slow queries. Again, in this short talk, we don't have time to go into that, but step 3, this is where the real magic happens. If you find out what's slow inside the database, what's taking all that time, and then you go analyze and fix it, that is going to have a huge impact, a positive impact on database performance. And then step 4, please go teach other people. Please spread the word about this. I've been doing it for many years, but every year, every few months, I meet people who don't know. So that's why I keep talking about it. So number 2, this is about indexes and indexing. And the first point I want to bring up, again, sometimes I feel silly mentioning this because this leftmost prefix requirement on indexes has existed for a very long time, but just a few months ago, new engineer right out of college had never heard of it. And they have a MySQL database to operate and get some performance out of, but they're not going to do that unless they first understand that in MySQL, indexes have this thing called the leftmost prefix requirement, and I'll just show you a very quick version of what I mean. Again, a lot to dive in later after the talk. So let's say that we have an index on columns A, B, and C defined in that order. The leftmost prefix means that you have to have conditions on those index columns in that order, starting with the leftmost one. So this is A in this case. So as the top example shows, you can have where A equals something. MySQL can use that index. And then if you want to use column B in that index, you have to have A and then something on column B. MySQL can use that. And if you want to use the full index, you have to have a condition on A, B, and C. You have to go from the left to the right as the columns are defined in the index. So to state this another way, what it means is that you can't, like in that top example, you can't have a condition just on column B or C without A, because then you're not using the leftmost prefix of that index. This is a very simple thing, but there are people who don't know this. And again, your index is not going to be used by MySQL unless it follows the leftmost prefix. The other thing is so the second point here, what indexes are used for? Over the last 20 years, I've learned that it's really fun to focus on those really interesting, advanced, cool optimizations where you have this complex query and it's not obvious like how MySQL is using the indexes or what, and it looks complicated, but then you find out that it's like super performant and it like works magic inside, and you want to go learn these like advanced cases. Hey, I like these things too, they're pretty cool. One such example is a technique called a deferred join, which you can Google later. Something like that. You actually write a bigger, longer, seemingly more complex query that turns out to be faster than a simpler query. That kind of stuff is cool. But the problem with focusing on those cool advanced things is you skip over the basics. You skip over the foundational pieces of how and when and where MySQL can use an index, or for what it can use an index. And that is these 5 things. MySQL obviously uses an index for conditions and a where clause. Hopefully everyone knows that. To optimize group bys, to optimize order bys. It will use an index for a covering index, meaning that it can take values only out of the index. So if you select, just select A, and then it can take the A values out of that index without having to pull them off disks or full rows, for example. That's a covering index. And then, of course, it uses them to join tables. There's obviously, again, more nuance to this. There's always, deeper to go. But these are the 5 basic things for which an index can be used. And it's important to understand that because when you're looking at a query and thinking, okay, how do I index this query with respect to the leftmost prefix? No matter how big the query is, how many tables, it really boils down to these 5 clauses, these 5 parts of the query. And moreover, although I don't list it here, generally speaking, MySQL can only use 1 index per query. And so what this means is you start running into conflicts, right? Like if you're trying to index to satisfy those conditions in the where clause, you may or may not be able to use that one same index to also satisfy, conditions in an order by or group by. Maybe you want to do a covering index, but you're joining tables, and so you need that one index to join the tables. And so you start to have this tension between these 5 things, and then you have to make trade-offs. But again, it starts with these 5 things, and then you use explain later to understand the MySQL query optimizer and the trade-offs it's making to make a final decision on which index is going to provide the most performance. But again, it starts with these 5 things. So when you're analyzing queries, you can boil it down to these 5. And that's important to do because this is universal and this is tractable, whereas trying to dive right into those deep optimizations is, like trying to learn swimming by diving into the deep end of a pool or diving into the ocean. So the last point, indexes are leverage against data and data access. So sorry about the somewhat low-res graphics here. I'll illustrate this. So we have this balance, and on the left side is the data that you need to serve. And data going up is better. That's better performance. And on the right-hand side, you have hardware and optimizations, which are the 2 basic things that you always have, the hardware running your database server and optimizations inside MySQL itself that it just applies automatically. You don't have to do anything about. With just these things, you can establish a certain balance where your hardware and optimizations will give you a certain amount of performance for a certain amount of data size and a certain amount of data. But if you keep piling on more data, then you're going to tip that balance, and it's just going to get slower and slower and slower. You have to add something to the other side to kind of reestablish that balance and give you more performance with more data, and more data seems to always be the case. But I'll talk about that in the third point. So what is that thing? Indexes. That's why I said indexes are leverage against this. When you have the right indexes, indexed properly on the right columns, et cetera, you can serve a lot more data with greater performance. And aside from certain products, like the talk I just went to before lunch, Ready Set and other, solutions that, might be added to this right-hand side, the hardware you're running on, the optimizations that you get, from inside MySQL, and then the indexes you add, that's the leverage you have against this ever-increasing amount of data and data access. So that's just a way to visualize the importance of indexes. Again, there's a lot more to say about this, but indexing is the second thing you need to learn after understanding that query response time is the goal. So what to do about this when you leave here? Go explain slow queries. So going back to the first section, find those slow queries, whatever tool you use, then use explain to see what indexes MySQL is choosing for those queries, those slow queries. Make sure that they're actually using a leftmost prefix. Maybe there's a query in there that's not actually being used. See that all the time. And try to understand how MySQL is using these indexes, of course, with the attempt to provide better indexes so the query isn't slow. Also, run a PT duplicate key checker. Duplicate indexes are a pretty common problem. Generally speaking, they slow down performance, not by a dramatic amount, but it's just a best practice not to have duplicate indexes running around. And again, for things to actually do, there's a great section in the MySQL manual called Optimizing Select Statements that will include all this basic information about indexing, but then also start to get into some of the more advanced indexing techniques. A lot to learn there, but short is our time. So number 3, data storage and access. So the first point I like to make, again, sometimes strikes people as odd, but I like to say that data is dead weight. What do I mean by that? Here's a trick we can play. There is a way to quote unquote optimize any database, any query, any workload such that the response time is virtually 0. Anyone have a guess what it might be? No. Truncate table. If you truncate a table and have no data, suddenly every query takes about 0 seconds to run. How magical is that? To be very clear, and for the recording, do not truncate your tables. Do not truncate your tables. It's a silly example, but it actually does go to show something. If you remove all the data, all the queries will be virtually 0 response time. That's because, again, data is dead weight. Data is work that MySQL has to do, that the queries have to do, that your application has to do. Data is like hauling these rocks or boulders up a hill. If the rocks are little, like they fit in your pocket, then you can run up the hill. But if the data rocks are huge, you're going to be, maybe you won't make it up that hill, or you'll be going very slow. So this is, again, good for new engineers to keep in mind. Don't go overboard with the data. Leading to the second point, a lot of experience shows that developers, teams, companies, they actually celebrate less. They only cope with more. And what I mean by that is, it's so many times I've seen application teams really celebrate when they drop 500 gigs of data, or when they do some sort of optimization and realize that a bunch of indexes are missing or queries weren't even needed, and they have, a cloud server that's, 16 cores and costing a lot of money, and then they drop the load and the QPS and all the data, and now they can, downsize the instance and it's cheaper. This happens all the time. I know that generally in the industry we talk about handling more data and how to deal with, data lakes and just more and more data. That's inevitable, but it's also the reason why you should focus on less data, like reducing things. Because if you don't, the future is going to catch up with you real soon. There's always going to be more data, so less is better. In fact, at the Ready, Set, Talk, I was happy to see them say that less work is better. Less work is better. And then the last point here, because we're running close to time, I'm sorry, is that access patterns and working set size frame performance. Access patterns mean how the application accesses both MySQL and the data and what it does with those data. And working set size is the percentage of the total data that's actually in memory and used most of the time. Generally, as a rule of thumb, we like to think that 20% of the total data is the working set, and so that's why you can have far less RAM than total data size. And the access patterns are important because a lot of times application developers and new engineers don't understand that there is a huge difference between a write-dominant workload versus a read-dominant workload, or like a split workload. And so reads and writes are the most basic access pattern. But there's a lot more nuance to access patterns that you can read about later. Things like, okay, even if your database is write-heavy, well, is it writing the same records, or is it writing like records kind of evenly distributed throughout the data? All of these access patterns, they frame the performance consideration. And what I mean by framing is if you have, for example, a write-heavy workload on a few sets of rows, well, that's a very narrow framing in which solving performance is going to be very tough. Your options are very limited because that's a tough workload. But if you have a read, 99% reads on, data, all over the place, well, that's a very different type of performance optimization, and you have a lot more options. So it's not that one database can just do it all. You have to understand what you're working with. So we're a little over time. So what to do here? Please archive, delete old data, but carefully, please, very carefully. Review your access patterns, especially of your slow queries, so that you can understand what framing that you're working with. And also consider other data stores and products. There are times when you need, other products to help provide additional leverage against that data and get you more performance. No product can do everything. MySQL is really great, but it has its limits like everything does. So again, I'm sorry that I couldn't give the full version of this. We only covered the first 3 of these. There's a lot more to learn. I hope that you take these action items after and start diving into them, and then follow the rest of the path. Go on to learn sharding, server metrics, replication, transaction, and data locking. That's a lot of fun. And then especially at the end, this stuff really applies a lot more to cloud performance, because in the cloud, you pay for all of that performance. So you have to be much more performance-minded in the cloud than you would have to be if you're running bare metal. Thank you.